morning, class 11th. We'll continue doing trigonometry. We are doing product formulae today. We basically will repeat what we had done and we will use those formulas to create new formulas. For example, we had sine A plus B as sine A cos B plus cos A sine B. Let me name this equation as 1. This equation as 1. Sine A plus B is sine A cos B plus cos A sine B. I always told you when it is sine A plus B, then sine cos sine will be there, and whatever the sine SIGN between A plus B is there, the same sign will come there. Now if I say sine A minus B, it will be equal to sine A cos B minus cos A sine B. This is second equation. This we have already studied. Now let us add equation 1 and 2 and see what happens. Let us add equation 1 and 2 and let us see what happens. If I add equation 1 and 2, what will happen? When I'll add these two, cos A sine B here is plus, cos A sine B is minus here. So these two terms will cancel from both the equations when we add equation 1 to equation 2. These two will cancel. So you will get sine A plus B plus sine A minus B as 2 sine A cos B. And we have got a new formula. Like we say 2 sine A cos B, 2 sine A cos B is equal to sine A plus B plus sine A minus B. This is the formula which we have obtained. 2 sine A cos B is equal to sine A plus B plus sine A minus B. Like we added these two equations, and the next step what we are going to do, we are going to subtract equation 2 from 1. We are going to subtract equation 2 from 1. Like we did add equation 1 and 2, now I will do subtract equation 2 from equation 1. When I'll subtract, what will happen is signs would change. It would become minus here, it would become minus here, and it would become plus here. So these two terms, instead of cos A sine B cancelling, now sine A cos B will cancel. Sine A cos B minus sine A cos B will cancel, and you will get sine A plus B minus sine A minus B would be equal to 2 cos A sine B. 2 cos A sine B, or if you write it first this side, 2 cos A sine B would be equal to sine A plus B minus sine A minus B. Time and again we are writing these formulas, sine A plus B, sine A minus B. From there we are obtaining, and further also we will use the same formulas to obtain other formulas. The reason being, the more you use it, the more you are going to remember them. So the best way is to keep writing them, keep using them, keep applying them to questions so that you keep getting. Now I have got two formulas. 2 sine A cos B, like I had written here, if you remember, 2 sine A cos B. 2 sine A cos B is sine A plus B plus sine A minus B. and 2 cos A sin B is sin A plus B minus sin A minus B. And how have we obtained? By simply adding. So in this I can write here sin A plus B plus sin A minus B. And here what have I obtained? Sin A plus B minus sin A minus B. 2 sin A cos B I have obtained as sin A plus B plus sin A minus B, which I have written here. 2 cos A sin B I have obtained as sin A plus B minus sin A minus B. Now I am going to rub out these portions and do the another part. We have dealt with sine. We have dealt with sin A plus B. We have dealt with sin A minus B. Now let us talk of cos A plus B and cos A minus B. Like cos A plus B, we told you in sin A plus B and in sin A minus B, you must remember that it is always going to be sin cos cos sin. And whatever is the sign between the A plus B is there, then it will come plus. If it is A minus B, then there will be minus. But here cos A plus B or cos A minus B, it will become cos A cos B sin A sin B. Like cos A plus B is cos A cos B minus sin A sin B. Cos A cos B, they are not sin and cos, they are cos A cos B sin A sin B. And it was plus here, it will become minus. In the first two, sin A plus B and sin A minus B, you must have noticed it was sin A cos B plus cos A sin B. But now when it is cos A plus B, cos A cos B minus sin A sin B, let us name it equation 3. And if I write cos A minus B, then it will become cos A cos B plus sin A sin B. That is fourth equation. We will do the same procedure with what we did with the first two equations, that we are going to add them once, we are going to subtract them once, and we will get two different formulas. Like add equation 3 and 4. If I add equation 3 and 4, what will happen is that minus sin A sin B plus sin A sin B will cancel. And what will I get? I'll get cos A plus B plus cos A minus B, because I'm adding cos A plus B plus cos A minus B. I'll be able to obtain 2 cos A cos B, or 2 cos A cos B. If you see the term 2 cos A cos B, and even if you see the term cos A cos B, you can always multiply and divide to get 2 cos A cos B into 1 upon 2 will be equal to cos A plus B and plus cos A minus B. So we get this formula, and we will write it here. 2 cos A cos B is cos A plus B plus cos A minus B, because at the end we will be rubbing this and again we will be discussing. That is why I am writing the formulas this side also. So what we did, we added the equation 3 and 4. These two terms cancel. Cos A plus B plus cos A minus B became 2 cos A cos B, and we can shift the side. So 2 cos A cos B can be written as cos A plus B plus cos A minus B. Now we will do subtract equation 4 from 3. Subtract equation 4 from 3. So when we will subtract, what will happen is that this term, this and this term will cancel. This is cos A cos B plus, it will come minus here, it will come minus here, it will come minus here, it will come minus here. So what will happen is this term will cancel. You will get cos A plus B minus cos A minus B is equal to minus 2 sin A sin B. Now because I am getting minus 2 sin A sin B, what I will do is I will change the sign. So I will make it 2 sin A sin B, and it will become cos A minus B minus cos A plus B. In this you have to notice this. First A minus B term will come, then A plus B term will come. Otherwise everywhere A plus B term is first. Whether it is sin A plus B, sin A plus B, cos A plus B. But in this case, when it is 2 sin A sin B, cos A minus B will come first. A minus B will come first. This is the point you will have to remember. In all the formulas, the last one will be always different. Cos A plus B. So, from sin A plus B, sin A minus B, cos A plus B, cos A minus B, we were able to obtain 4 more formulas which we have written here. 2 sin A cos B, 2 cos A sin B, 2 cos A cos B, 2 sin A sin B. 4 more formulas we'll obtain from the same equations. Let us see again. Like I have sin A plus B plus, if I added, I got plus sin A minus B as what? I have got 2 sin A cos B. When I added sin A plus B and sin A minus B, I got 2 sin A cos B. Now what I am going to do is, in place of A plus B, I will write C, and in place of A minus B, I will write D. I will replace A plus B with C, the letter C, and A minus B I will replace with the letter C. So it will become sin C plus sin D. Sin C plus sin D. Now I have to change them also in terms of C and D. A plus B is equal to C, A minus B is equal to D. When you will add them, you will get A as C plus D by 2 and B as C minus D upon 2. For example, you can see it here. A plus B is C and A minus B is D. When I add, I get 2A is equal to C plus D, or A will be C plus D upon 2. When I subtract, I'll get 2B as C minus D, or B will be C minus D upon 2. So I have to express A and B in terms of C and D, because here it is sin C plus sin D. So it will become 2 sin C plus D upon 2 and cos C minus D upon 2. This is another formula. Sin C plus sin D becomes 2 sin C plus D upon 2 cos C minus D upon 2. So sin C plus sin D becomes 2 sin C plus D upon 2 and cos C minus D upon 2. We are getting the formulas from one only, sin A plus B, sin A minus B. But we are getting in different forms because we will be applying these formulas to different situations. Now, if I subtract when I had subtracted, what I had got sin A plus B minus sin A minus B, we had 2 cos A sin B. If you see the formula here, Sin A plus B minus sin A minus B is 2 cos A sin B. Again A plus B is replaced by C. So sin C minus sin D will be equal to 2 cos C plus D upon 2 and sin C minus D upon 2. We have got another formula. Sin C minus sin D. Sin C minus sin D is 2 cos C plus D upon 2 and sin C minus D upon 2. We have got these formulas. From sin A plus B, sin A minus B, sin A plus B, sin A minus B. Similarly, from cos A plus B plus cos A minus B and cos A plus B minus cos A minus B. Let us see what do we obtain. Next we are writing is cos A plus B plus cos A minus B was 2 cos A cos B, 2 cos A cos B, 2 cos A cos B, 2 cos A cos B. Now what will happen is it will become cos C plus cos D will be equal to what? 2 cos C plus D upon 2 and cos C minus D upon 2. Remember that cos C plus cos D will be 2 cos C plus D upon 2 cos C minus D upon 2. Here it is. Cos C plus cos D will be, because we said what was it? Cos A plus B cos A minus B were 2 cos A cos B. So we obtain that 2 cos C plus D upon 2 and cos C minus D upon 2. Now if it is, let us see the last one. Last one was cos A minus B. It was cos A minus B minus cos A plus B was equal to 2 sin A sin B. This is the only formula in which it is cos A minus B comes first and minus cos A plus B. Otherwise A plus B everywhere in the first three formulas you will notice A plus B has come first. A plus B has come first. Now what I am going to do is the same thing. Cos A minus B we had put what? A minus B we had put D. So cos D, only in this formula cos D minus cos C. Only in this formula it is cos D minus cos C will be equal to 2 sin C plus D upon 2 and sin C minus D upon 2. So it comes out to be 2 sin C plus D upon 2 and sin C minus D upon 2. Based on these formulas, sin A cos B plus cos A sin B, sin A cos B minus cos A sin B. Cos A cos plus B was cos A cos B minus sin A sin B. I have written earlier also, but I am writing it again for you. Cos A minus cos B is cos A cos B plus sin A sin B. So from these 4 formulas we have obtained 8 more formulas. We have obtained 8 more formulas here, and we are going to show you that how will we get more formulas further in there. We are going to do a question based on whatever formulas, around about 12 formulas we wrote to you. before I came to this question, and we are going to do few questions based on these formulas so that you understand that what was the need of creating those formulas. Like if I have, he says prove that, question 1 is sine 20, sine 40, sine 80 is equal to root 3 upon 8. I have to prove sine 20 into sine 40 into sine 80 as root 3 upon 8. What I did was, I multiplied this left side by 2 and divided by 2. I'll tell you why did I do that. I did half divided by 2 and multiplied by 2. I get 2 sine 20 sine 40. I get 2 sine 20 sine 40. I kept sine 80 outside. You know the formula. You know the formula that 2 sine A sine B. 2 sine A sine B. 2 sine A sine B was cos A minus B minus cos A plus B. The last formula I told you is different. It is different. 2 sine A sine B is cos A minus B. In everywhere A plus B comes as the first term, but only in this formula the first term comes as cos A minus B. If you look what we have done it, you will find cos A minus B minus cos A plus B. So we got 2 sine A sine B, 2 sine 20 sine 40. Instead of A I have got 20, instead of B I have got 40, so I can apply that formula to sine A sine B. What is the formula for sine A sine B? As I wrote to you, cos A minus B, cos 20 minus 40 minus cos 20 plus 40. So let us see what do we get. Cos 20 minus 40 will be cos minus 20, and if you see, add sugar to coffee, then it will fall in the fourth quadrant. Cos minus 20 will fall in the fourth quadrant, and in fourth quadrant we have cos minus theta is cos theta. So cos minus 20 will become cos 20 minus cos 60. The value of cos 60 is known. Value of cos 60 is 1 upon 2. So 1 upon 2 into sine 80. I have reduced this to this half cos 20 minus half into sine 80. I'll multiply now. 1 upon 2, I'll bring sine 80 inside. Cos 20 into sine 80. Cos 20 into sine 80 minus 1 upon 2 sine 80. If you take 2 LCM here, so 2 will come here and the 2 will come outside. It will become 1 upon 4 into 2 cos 20 sine 80. 2 cos A sine B. Now it comes cos A sine B. 2 cos A sine B. 2 cos A sine B. If you look at the formula, you will get the formula as 2 cos A sine B was when we were subtracting. We were subtracting sine A plus B minus sine A minus B. 2 cos A sine B was sine A plus B minus sine A plus B, A minus B. So 2 cos 20 sine 80. Instead of A I have got 20, instead of B I have got 80. So 20 minus 8, 20 plus 80, sine 20 plus 80 minus sine 20 minus 80 and minus sine 80. 20 plus 80 will become sine 100. This will become minus sine minus 60. It will fall in the fourth quadrant, and here it will be sine minus theta is minus sine theta. Cos minus theta is cos theta in the fourth quadrant, and sine minus theta is sine theta in the fourth quadrant. Minus sine theta. It is minus sine theta. So it will become minus sine 80, it will become plus sine 80. Plus sine 60, sorry. 20 minus 80 is 60. So it becomes plus sine 60. Sine 100 plus sine 60 minus sine 80. Now sine 100 can be written as 180 minus 80. Sine 180 minus 80. The value of sine 60 is root 3 upon 2 minus sine 80. Sine 180 minus 80 will come into the second quadrant. In second quadrant, sine is positive, so it will remain sine 80. It is minus sine 80. Both will cancel with each other. 1 upon 4 into root 3 upon 2 will give you root 3 upon 8. This is the question. The second question, based on the formulas which we did, this is on the basis of sine C plus sine D, cos C plus cos D. It is sine A plus sine 3A plus sine 5A plus sine 7A upon cos A plus cos 3A plus cos 5A plus cos 7A. Now the question is, how do we combine? I can see that formulas will be either we'll have to combine 2 sine C plus sine D for applying sine C plus sine D. But the question is choice. How do I make the choice that I should combine sine A, sine 3A, sine 5A, sine 7A? Which one should I choose? Look here, A plus 7 will give me 1 plus A plus 7A will give me 8A. 3A plus 5A will give me 8A. So I should choose where the combination, when we add, we get the same result. Like if I add A plus 3A, I'll get 4A. If I add 5A plus 7A, I'll get 12A. So there is no point. If I take any one, sine A plus 3A, it will be 10A. 5A plus A will be 6A. So I don't get anything common. But if I combine sine A plus sine 7A, sine A plus sine 7A, and sine 3A plus sine 5A, what will happen? When I'll do sine C plus sine D, it will be 2 sine C plus D upon 2. So A plus 7A will give me 8. 3A plus 5A will give me 8. Same logic has been applied to the denominator. That I made the pairs cos A, cos 7A, cos 3A plus cos 5A. Now sine C plus sine D. Sine C plus sine D is 2 sine C plus D upon 2. 2 sine C plus D upon 2 and cos C minus D upon 2. So here in place of C I have A, in place of D I have 7A. I can reverse the order, it will not make any difference. Because it is plus, so it does not change anything. I could write 7A first and 7A A later, it doesn't make any difference. A plus 7A. So A plus 7A is upon 2, A minus 7A upon 2. And why it is not going to make difference, please understand. Because in the sign it is plus, whether you write A plus 7A or 7A plus A, you will get plus. In this I get minus 6A. I get minus 6A upon 2, I will get minus 3A. Cos minus theta is always cos theta. So even if negative sign is coming inside cos term, it does not matter, because cos minus theta, which falls in the fourth quadrant, and it is going to be positive. Cos minus theta is cos theta. That is why I am not bothered of changing the order. Similarly here, sin 3A plus sin 5A will be 2 sin 3A plus 5A upon 2, 3A minus 5A upon 2. So we applied sin C plus sin D. Sin C plus sin D is 2 sin C plus D upon 2 and cos C minus D upon 2. Here C was A and D was 7A, so we applied that formula. In the denominator I have cos C plus cos D. Cos C plus cos D is 2 cos C plus D upon 2 and cos C minus D upon 2. Because in the cos formulas both the sign cos will come or both the signs will come. So cos C plus cos D, both the causes will come, and cos C minus cos D, both the signs will come. So here cos A plus cos 7A will be 2 cos A plus 7A. First we will add these two, divide by 2. Then cos A minus 7A upon 2 plus cos 3A plus 5A upon 2 and cos 3A minus 5A upon 2. So a plus 7a is 8. 8 divided by 2 will give me 4a. A minus 7a is minus 6a divided by 2 will give me minus 3a. And I told you cos minus theta is always cos theta. It falls in the fourth quadrant. Cos minus theta, so it will become cos 3a, so it doesn't matter. Plus 2, 3a plus 5a is 8a. 8a divided by 2 will give you 2 sine 4a. And again cos 3a minus 5a upon 2 will give you minus cos minus a. Cos minus a will become cos a. Similarly 2 cos a plus 7a upon 2 will give me cos 4a. Cos a minus 7a upon 2 will give me cos minus 3a, which will again become cos plus 3a. And 2 cos 4a cos minus a. So cos minus 3a will become cos plus 3a. Cos minus a will become cos a. Cos minus 3a will become cos 3a, and cos minus a will become cos a. Out of the numerator terms, I could take 2 sine 4a common, because 2 sine 4a is coming here, 2 sine 4a is coming here, so I have taken 2 sine 4a common. Here in the denominator I have 2 cos 4a and 2 cos 4a, which I have taken out common. When I have taken these terms common inside, cos 3a plus cos a, cos 3a plus cos a, and that will cancel from numerator to denominator. And I will get 2 will cancel. I will get sine 4a upon cos 4a, and sine 4a upon cos 4a will yield me tan 4a, which I had to obtain. It is equal to tan 4a. In question number 1 we did was sine 20, sine 40, sine 80. Now the question is cos 20, cos 40, cos 80, and we have to prove it equal to 1 upon 8. So what we are going to do is we are going to divide this by 2 and multiply it by 2. So I get the form 2 cos a cos b. So I can apply the formula of 2 cos a cos b. The formula for 2 cos a cos b was cos a plus b plus cos a minus b. So 2 cos 20 cos 40 cos a plus b 20 plus 40 plus cos 20 minus 40, and cos 80 is outside. 1 upon 2, 20 plus 40 is cos 60. We know the value of cos 60. Plus cos minus 20. Cos minus theta is cos theta only. So it will remain cos 20. 1 upon 2 cos 20 multiplied by cos 80. I took out the LCM 2 here and brought the 2 outside. It became 1 upon 4 plus cos 80 plus 2 cos 20 cos 80. Again it is 2 cos a cos b. We are going to apply the formula cos a, 2 cos a cos b is equal to cos a plus b plus cos a minus b. So cos 80 plus cos 20 plus 80 plus cos 20 minus 80. Cos 80, 20 plus 80 is cos 100. Cos 20 minus 80 will be minus cos minus 60. Cos minus theta is again plus cos theta. So it comes cos 80 plus cos 100 plus cos 60. Cos 100 can be again written as cos 180 minus 80, which will be in the second quadrant, and in the second quadrant cos is negative. So cos 80 minus cos 80 it will become, so that cos 80 and minus cos 80 will cancel, and the value of cos 60 is 1 upon 2. It is plus here. So cos 60 is 1 upon 2. So 1 upon 4 into 1 upon 2 will give you 1 upon 8. Thank you.